So when we want to add fractions, we must have a common denominator to add or subtract. Okay, so does this already have a common denominator? Yeah, so when we add, we do not add the denominator. So we keep that same denominator of 5 and just add the numerators or subtract the numerators. So 6 over 5. So 2/5 plus 4/5 is 6/5. Or 1 1/5. But we always leave it as improper. We don't use mixed ever in high school. Yeah, it's true. Yeah. It's just better. Yeah. Okay, 2/3 plus 1. 2/3 plus 1. So what do we need? We need the 1 over 3, but it's a 1. So we need to turn 1 into a fraction. How do we turn 1 into a fraction? It'd be 3 over 3, because this would be 1 over 1. And so we would multiply the top and the bottom by 3. So 2/3 plus 3/3, 5/3. Okay, keep the same denominator, just add the tops. Okay, the next guy. Do you want to try them on your own? Yeah, you did. You have to, this is foundational. You got to be able to add and subtract fractions. So we're doing a little mini review, because you're going to use that, obviously, in this lesson. All right, to make the 21, what do we do to 7? Times the top, and what we do to the bottom, we have to do the top. 6 over 21 minus 3 over 21 is 3 over 21. We always reduce if we can. Can you 3 go into 21? Yes, so it would be 1 over 7. Always reduce. Okay, multiplying. Multiplying is so much easier. It really is. Why? Because it's way simpler. Go straight across. Okay? Yeah, there's two options. We can go straight across, or we can actually reduce first and then multiply. So let's go straight across, sure. 6 times 4, 24 over 5 times 3, 15. Can we reduce this? 8 over 3, so you divide it, no. 8 over 5. We could divide both of these by 3. You can also check in your calculator. You can go 24. This is really like cheating, actually. Math, enter, 8 over 5. Right? So you could divide the numerator and the denominator by 3. Okay, so you 24 over 15, and then I go math, enter, math, enter. Okay, so before we multiply 3 over 2 by 4, what are we going to do to 4? Put it into a fraction, so put it over 4 over 1. 4 over 1. So now we can multiply sort of straight across. 3 times 4, 12. 2 times 1, 2, which equals 6. All right, try the last one on your own. And check to see if it can be reduced. You're welcome to use your calculators if you have to. Can you reduce 8 over 25? No, you can't. Doesn't reduce. Okay. So you have your chart. You have this chart you're going to fill in. Everyone knows how to type in a square root, right? Everyone knows how to type in a cube root? Okay. You probably don't know how to type in a fractional exponent. Okay, we're going to find out. So, for example, this first guy, to type in this fractional exponent, x is our 1. Next time it'll be 4 to the power of 1/2, 9 to the power of 1/2. So we're going to enter it each time. So when you have a fractional exponent, so we use the hat for the power of, or what Anthony calls the caret. Thank you. You have to put your fraction in brackets so that the whole thing is raised to the exponent. Otherwise, it would just raise the power of 1 and then divide it by 2. And we want the power of 1/2. So you'd actually have to put that in brackets. So in your calculator, it would look like 1 power of bracket 1 over 2. Now some of you have fancy calculators. You actually don't need to put the brackets. It'll automatically put it up high for you. Then you'd have to, if yours looks like this, then that's how you enter it. Okay, if you have a different calculator, you can put your hand up and I can show you. It's a lot easier actually if yours is different. So the next one would be 4 to the power of bracket 1 over 2. Okay, and so go through these. It literally moves it to an exponent. Yes, so you're good. So to get out of the exponent, you would have to push arrow. Yeah. Okay, so can you please fill in this chart? If you need help, put your hand up and I'll help you. Yes, some of you are no. Okay, so you should have had, when we take the square root of 1, it's 1, 2, 3, 4, 5, 6, 7. And what did you find here? Same thing. So what conclusion can we draw? Square root of x is the same thing as x to the power of 1/2. Interesting. Okay, so that's our first conclusion. So cubic root of 1 is 1, cubic root of 8 is 2, 3, 4, 5, 6, 7. So when we rose it to the 1/3, it was equal to the same thing. So what conclusion can we draw here? The cubic root of x. Yeah. So what could we say about x to the 1/4 then? It's the same as the 4th root of x. The 4th root of x. Yeah. Okay, then entering 2/3, you make sure your brackets are there when you entered that one, right? And you should have had 1, 4, 9, 16, 25, 36, and 49. And did you have the same thing here? Interesting. Yes, Anthony. No, not really.
But they aren't exactly the same because when I did negative 4 to the power of 1/2 gave me.
Oh, we haven't learned about negative exponents yet. We'll learn about negative. We'll learn about negative. That's different. Okay. So x to the power of 2/3 is equivalent to the cubic root of x squared. Okay. So that leads to the next page and what we're going to learn about today. So radicals and exponents. You might have been wondering, why are radicals and exponents in the same unit? No? Well, radicals are just fractional exponents. Really the same thing. So our conclusions was x to the 1/2 was the square root of x, right? We also had the conclusion that x to the 1/3 was cubic root of x, and x to 2/3 cubic root of x squared. So therefore, here are our rules, our general rules. If you have x to the power of 1 over n, x to the power of 1 over n, that would be equivalent to the nth root of x. Make sense? If you had 1/2, it was the square root of x. 1/3 is the cubic root of x. So that bottom part is what is the root, the index. Okay, it's the root at some number, where n is an element of the natural numbers. Natural numbers. So n has to be an element of the natural numbers. This little n e here means element of, guys, way too much talking going on. Natural numbers. So n has to be a natural number. What are natural numbers? 1, 2, 3, counting numbers, right? Okay, so moving on. What if we had x to the power of m over n? Or let's say, should we say a over b? I'm going to use a over b instead of m over n. A over b. So what happened to the a? No, when we converted it to a radical, it's the power. So And then the bottom is the root, the index. So one way to think about it, so that would be equivalent to b, the bth root, okay, x to the power of a, or you could also do the bth root of x and then all to the power of a. So the exponent can go on the inside or on the outside. Either spot, doesn't matter. So here's my little trick to remembering what's what. When you have a over b, okay, your exponent of a over b, it's flower power over root. So the top is the power, the bottom is the root, or the index. Okay? So flower power is always on top of the root. Okay, so flower is the flower power, so the power on top, and the root's on the bottom, the root, which is our index. It's like Super Mario's, yeah. That was my childhood. Duck Hunt and the original. Yeah, that came out when I was a kid, like the first edition. Yeah, I'm pretty old. Okay, so given a power with a decimal exponent, the decimal can be converted to a fraction. So if we had 2 to the power of 1.2, how do we change 1.2 to a fraction? Okay, first of all, you should know. Okay, what place value is this? The tenth. So we're going to take 12 over 10. Or what can you do in your calculator? Math, enter, enter. So 1.2. It just turns off on me. It's so mean. Math, enter, enter. So does 12 over 10 equal 6 over 5? Yeah, it's just not reduced yet before. So 6 over 5. Okay, let's change this to a radical. So which one would be the index? Or the root? The 5. And the power is 6. That's how you write that as a radical. If a radicand is a number, you can evaluate a power with a fractional or decimal exponent. Okay, so for example, if we have 27 to 4 over 4/3. So when we have a fractional exponent, it's very difficult. Yeah. Okay, this is the tenths place, right? So you take the 1.2, change it, because we're moving this over to 1 to tenths place, we put it over 10. So that reduces to 6 over 5. That's us turning it to a fraction. Okay, if you had 1.56, what? You take the last decimal place. What's that? That's the 100. So you have 156 over 100. Okay, if you have 20.3, what place value? So it'd be 203 over 10, because that's a tenths place. That's called the tenths place. And then you reduce the fraction. Or you could put in your calculator and push math, enter, enter. Okay? So that's just changing this to a fraction, because we had to put in a fraction before we can put in radical form. Okay, listen up, guys. Sorry. When you have a fractional exponent, could you just figure that in your head? Probably not, right? Probably can't look at that and tell me what number that equals. So when we have a fractional exponent, we want to change it to a radical. So you always want to remember that fractional exponents are radicals. That's what they are. You want to change it to a radical if you actually want to evaluate it. So 27 goes in the house. What would be my index or my root? 3. And what would be the power? 4. Now I'm going to put the 4 on the outside instead of on the inside, because it's always easier to make a number smaller first, then bigger. If you're going to use your head and not your calculator. Yeah. Nope. Could be either place. The reason why I put on the outside is I'm gonna actually take the cubic root of 27, because could we do that with our head? Yeah, we should know what the cubic root of 27 is. What is it? 3. So that equals 3 to the power of 4. And anything to the power 4 is like squaring it twice. So 3 squared is 9. 9 squared is 81. And there we go. Okay, so when you're actually evaluating these problems in your homework, I want you to avoid using a calculator. Change it to a radical and then actually evaluate it from there. Okay, because we're going to get to a point where we have variables instead of numbers inside, and if you've just been typing this into your calculator your whole time, then you're going to have a hard time transferring those skills. That's why I want to practice converting it to a radical and then evaluating it from there. Okay? All right, so we're almost done, I believe. Yeah, close. We're getting there. Okay, find the exact value without a calculator. So, if we see a fractional exponent, what are we going to turn it into? A radical. Okay, so who's the root? 3 power is 2. Okay, cubic root of 27, so always do the root first because you can make it a smaller number. Cubic is 3, and then square that is 9. Okay, so once we change it to radical, you can easily evaluate it. All right, so again, I see a fraction, so that means I'm going to change it to a radical. So the negative 8 goes inside. What's the power? 1. Do you have to write the 1? No. And the index is 3. Cubic root of negative 8. Negative 2. Because we know the cubic root of 8 is 2, so it'd be negative 2. All right. What's wrong with this picture right now?
The fraction's inside the bracket.
Okay, so that's okay. We can have a fraction inside the brackets. Is there anything wrong with 0.5? It's not a fraction. So what is 0.5 as a fraction? 1 over 2. Okay, so what's the index? Or the root? Which one would be the root? The 2. Do you have to write a little 2 here? No? And what's the power? Well, because when the index is 2, we don't actually have to write it. Because it's a square root, right? Square roots have an index of 2. And then power of 1. So square root of 25 over, so just like multiplication, we could split up the radical when we have division. So what's a square root of 25? 5. What's a square root of 4? 2. Okay. Do you want to try the last two on your own, or do you want to do it together? Try it. Remember, the 4th root is like taking the square root twice. Add the 4th root of 81 cubed. So 4th root of 81 is square rooting twice. Square root of 81, 9. Square root of 9, 3. So 3 cubed is 27. Okay. The next one, 0.75, you have to change to 3 over 4. You can use your calculator to do that. 0.75, math, enter, enter. So you have the 4th root of 16, all cubed. So 4th root of 16, square root twice. Square root of 16, 4. Square root of 4, 2 cubed is 8. There you go. Okay. Turn the page, a couple more, and then we're done. Okay, so what if we don't have numbers? What if we have variables? Well, the same rules apply. So we're going to go opposite. We're going to change this to a fractional exponent. So what would be what over what? 2 over 4, can you reduce that? Yeah, it become 1 over 2. Yeah. Because power over root. So the power over the root. 2 over 4. No, because there's x is a variable, so we can't solve any further. So we're just simplifying by eliminating all radicals. That's what they want us to do. Okay. The next guy, now, they don't have the same power. So then the power is just 1. They have to have the same exponent if we're going to pull that out. Okay, so this would be, our radicand is x to the 8, y to the 12, all to the power of what? What's my 1 over, what's my index if you can't see it? 2. Okay, we could take this one step further. With exponent laws, if you have a power to a power, does anyone remember what we do with those? Multiply. If we have power to a power, we multiply them. So that would be 8 times a half, 4, and 12 times a half, 6. Which makes sense because we're square rooting it, so it cuts them in half. Okay. So the first guy, what would be the exponent? 4 over 4. Power over root, which happens to be 4 over 4. And the next guy, power over root, 5 over 2. If you don't see the index is 2. If you have to, write it in so that you remember. So power over root. Okay, we are multiplying. When we multiply, what do we do with the exponents? Add them. We add the exponents. So we want 4 over 4 plus 5 over 2. How do we add fractions? Common denominator. So what can we do to 4 over 4? Divide by 2. We could also make that 2 over 2. Would that be the same thing as 4 over 4? Yeah, they're both equal to 1. Plus 5 over 2 gives you 7 over 2. You could have also made this 10 over 4, and then you would have 14 over 4, and then reduce to 7 over 2. You never add the denominator. We keep the same denominator, just add the top. Okay? All right, next guy. Xy to the power of, what's the exponent? 1 over 2. 1 is the exponent, index is 2. And last guy, b to the power of 2 over 3. Yeah, you got it. Okay, so your homework today, it's not that bad actually. A lot of it's really quick. Joel, you're always the first to say something negative. Number 3 to 12 and 5 to 17. So you want all the numbers in between. Okay, so you have lots of time today. Unless you guys wanted to play that game again, or do you want homework time? Homework time. Okay, a lot of you are saying homework. So if a lot of people finish early, then we'll play some of the game at the end of class, okay? If a lot of you are done.